going to topic 4. My plan is to get lesson 4.1 done. I've yet to achieve that goal today, but I'm going to get it mostly done at least, okay? To where you can go in and look at the homework, get most of the homework done. I may have to answer some questions to help you through it tomorrow, but it should get us in the right direction. Chapter 4 is all about rational functions, I believe is what's probably in the chapter. Okay, we're looking at the very basic today, just the reciprocal function, okay? When the x is in the denominator, what the graph looks like, and going from there. Now, we're actually going to start off with what technically should be some Algebra 1 review, but I don't know if you guys talked about direct and inverse variation in Algebra 1 or not. It's in there, but I know it sometimes gets skipped because it's not always in the standards, so we're talking a little bit about it today. So we're going to kind of go through the differences and look at some of the different problems that you'll see, okay? So when we talk about variations, we're first going to talk about inverse variation. Inverse variation is a relation between two variables such as that one variable increases, the other variable increases proportionally. So basically as one set of data goes up, the other set of data is going up. I just totally goofed that, didn't I? Okay. I'm talking about direct variation. But what did I say I was talking about? Inverse. Rewind, please. Let me try that again. Inverse variation. As one variable increases, the other variable decreases. Sorry, I had a moment. Okay, so as one item is going up, the other item is going down. We end up with graph that is these outward two curves. And you'll see some of these graphs, it'll be multiple choice. So you'll see some of these graphs in homework, okay? Where basically if you pick a set of x and y values, as one value goes up, the other value goes down. Now, vocabulary-wise, inverse variation is usually phrased as y varies inversely with x. You'll see that in some of our practice problems. The best equation is y equals k divided by x. Okay? Usually when they ask you to write an equation, that's what they're looking for, the y equals. Now, there's an alternate equation listed here too. xy equals k. We're going to use that some. You could honestly write that as a final answer for me too. Savas will probably want the one that is y equals though. Now, in all of these, k. Are we familiar with k? When you throw something like k in, k is what we call the constant of variation. It represents a number, and the number for that specific problem that relates x and y. Okay, so what is that relationship between the two? Now, our other option besides inverse variation is direct variation. Direct variation, this is the one where as one variable increases, the other variable also increases proportionally. That's why you'll see your graph is a straight line, because as x goes up, y goes up. So the farther right you go, the farther up you go. So direct variation is always a line through the origin there. Vocabulary-wise, y varies directly with x. So you'll see, you'll know it's a direct variation if you see that phrase. We have the equation y equals k times x. So when it's y equals, you're doing the k times x. We have an alternate equation, which is how you can find k, and that is y over x. Okay? You're going to want to keep referring back to these equations. Okay? You've got them on your paper. Keep referring back to them. We're going to use them in a lot of our examples today. In this first section, we're going to talk about identifying inverse variations. So we're going to look at each table of values, and we're going to decide, are they an inverse variation? Does it represent a direct variation? Or you get the neither option also. If it represents direct or inverse, we're going to write the equation. Now, I'm going to refer to our alternate equations on these a lot, because if it's inverse variation, all my x's and y's will multiply to be the same number. If it's direct variation, all my x's and y's will divide to be the same number. Look at A. We have 4 sets of ordered pairs. do you see a multiplication connection between your x's and your y's?
6.
Or do you see a division connection between your x's and y's?
Multiplication. 6.
Okay. So we can agree that 1 times 6 is 6. 2 times 3 is 6. 3 times 2 is 6. 6 times 1 is 6. I know, it's a little overboard for me to do all 4, but here's the deal. It has to work with all 4. Okay, it needs to work with all 4. So with that in mind, we just showed that x times y equals 6. Okay, go look up above. Is this a representation of direct variation or inverse variation? In other words, where does it say x times y equals a number?
I thought it was direct.
Where does it say x times y equals a number?
Oh.
Okay. Now, because what did we just do? We just said all of our x's times all of our y's always equals 6, right? So I'm looking at this piece right here. I know, you guys were looking, we got to get all straightened out. So, we can agree that this is inverse variation, yes? Can you tell me what the k value is? We just multiplied all those x's and y's, and every time we got 6. So that is my k value. Now, it said if it's direct or inverse, write an equation. Well, we can write one of 2 equations. Technically, did I already write an equation up here? We already said x times y equals k. Or in other words, equals 6. Or, what's the y equal version? And one way, how do you solve this for y? How do you get y by itself? Divide by x. If it's x times y, divide by x. And if it's x times y, what are we going to get? If we divide the x, you're going to have 6 divided by x. Now, go back to the top of your page. Does this match? Inverse variation, k, y equals k divided by x. Ours is y equals 6 divided by x. You're talking to me, technically, I take either of those 2 equations. I'm going off the top of my head because I didn't think to check it. Well, I got here late this morning, so I didn't get a chance to check. But they're probably going to want the y equals equation. Okay? If not, you've got the other equation right there. Questions on that one? Okay, let's look at B. Is there a multiplication connection, or is there a division connection?
No.
I'm just getting lots of no's. So multiplication failed.
Yeah.
2 times 10 is 20. 4 times 8 is 32. Do we see the failure?
Yeah.
Okay, right there, I didn't even have to go past the first 2. I figured out real quick that those are not the same. So what do I know right now? This is not inverse like the last one. Okay? Because I tried to do x times y to get a k value, and I failed at it. Okay? Because I can only have one k value. What's the other alternative? The other alternative is do y divided by x to get a k value. Did you try that?
Yeah.
It didn't work either?
No.
Okay, so if I try a couple of y divided by x, so 10 divided by 2 is 5. 8 divided by 4 is 2. And I can stop there, can't I?
Yeah.
I got 2 different numbers. So now y divided by x didn't work. So this tells me that this is not direct. It's not direct because it doesn't complete the form y divided by x. If it's not inverse and it's not direct, it is neither. Okay? C.
Division.
Okay. Are you trying it? Is division working?
Division.
Now, keep in mind, which way do I need to do the division?
This
Y.
Yeah, if we're going to try division, we need to do y divided by x. So, 8 divided by 0.2.
4. 3. No, it's
Point something.
40. Yeah.
8 divided by 2/10 is 40.
Huh?
Yeah.
If you're taking 8, a whole number 8, and you're dividing it into pieces that are 2/10, there's 5 pieces in each whole. You're taking 8 whole, I don't know, pieces of candy. And each person gets 2/10 of a piece of candy.
That's not very much.
No, it's not. But each person gets that much. You're taking those 8 pieces and you're dividing it up into small pieces. So you end up with 40 pieces.
Alright, so what's the next one be about?
20 divided by 0.5.
40.
Maybe 40.
If it's division and they all have to be the same, I would.
Now, and here's, guys, think about it. 0.5 is 1/2, yes?
Yeah.
If you take 20 and you divide it by a half, not by 2, but by a half, 20 divides into how many halves?
40.
40 halves, yes? Okay. Okay.
Hey,
What about 40 divided by 1.0?
40.
And 60 divided by 1.5?
40. Yeah,
40.
right about the-
Okay. Now, with that in mind, which form does this fit?
Direct.
Okay, if you go back up top and look, y divided by x equals k is a representation of
Yeah.
direct. What is my k value?
40.
40.
We found k to be 40. And you might want a calculator for homework in case you run into similar issues, right? That didn't go well for those of you that didn't have the calculator. Just saying. Now, write an equation. One equation. We just did y divided by x and got what? 40. Okay? It's an equation. It's true. What's the y equals version? If it's y divided by x, what's the opposite of dividing by x?
Y equals K.
Multiplying by x, so 40 times x. So y equals 40x. Or again, you have this information up top, yes? What does direct look like? Those two things, so if k is 40, y equals 40x. Okay? Now, I don't know if anyone tried to do x divided by y instead. Okay. And here's the deal. I don't know if you continued it all the way through.
It's the same.
So if you did x divided by y, you got the same answer all the way through. So did you figure out that it was direct? Yes, you can still figure out it's direct. What's wrong with your problem, though?
Okay.
You're going to have the wrong k value, so you're not going to get the right equation. So it is valid. It will divide. It'll just give you a different value that's not the right k. So that's my warning. Make sure you're doing y divided by x. Okay? Okay. Moving on. We're going to try some word problems. Now, what's the first job with a word problem? You have to
Read it.
read it, not skip it. Okay? Read it, not skip it. And we don't just read it once and give up. We read it, read it, read it. We break it down, and we try it.
Until
No, we get it past gibberish. Okay, so I'm going to read it first. Suppose that x and y vary inversely, and x equals 10 and y equals 3. Write an equation to represent the inverse variation, then find the value of y when x equals -6. Okay. Gibberish the first time through?
Yep.
I'm not going to argue that. Okay? Reread it a couple more times if you need to. But then eventually, break it into pieces. Let's just look at this first sentence. Suppose that x and y vary inversely, and x is 10 and y is 3.
So it's inverse.
Okay, keyword. Did we get that?
Yeah, very inversely.
It says varies inversely.
So it'd be a y equals K, right?
My equation options for vary inversely, if you go back up top, are y equals k over x and xy equals k. I know those are the two equations I'm working with because I saw the word, or words, varies inversely. Okay? Now, in that same sentence, it tells me x is 10 and y is 3. If I know x and y, what can I find? Your k. They're giving you an x and y value, so you can find k. So let's use x times y equals k. X is 10, y is 3. 10 times 3 is
30.
30. So we just found our k value to be 30. Now,
Neat, right?
if you go to the very beginning of the next sentence, it says, write an equation to represent the inverse variation. Well, officially, either of these equations work. My preference is going to be the y equals 1. So if we have y equals k over x, but what did we just find?
Okay.
K is 30. So I can write this as y equals
30 over x.
30 over x. So you use your x and y to find k. Yes?
Yeah.
Okay. That takes care of sentence 2. Only one more. Then, okay, final step. Find the value of y when x equals -6.
Negative 6 times y.
You are.
What am I going to do with that -6?
Plug it in there.
We're going to plug it in right here, folks. Okay? You wrote the equation. Now, find y when x equals 6. So y equals 30 divided by -6, which is -5.
Okay.
Okay?
That was quick.
That's that first problem.
Not bad.
It was gibberish, I know. There's a lot to it. But my point is, look for the pieces. Break it into a sentence at a time. Okay, let's see if B goes better now. Suppose that x and y vary inversely, and x is 6, y is 1/2. Write an equation to represent the inverse variation, then find the value of y when x equals 15. Okay, what did you spot in this first sentence?
Very inversely.
Okay, varies inversely, so go to the top of your page and say, oh, okay, that means I can use y equals k over x or
X, Y equals K.
xy equals k. And if you noticed on this first equation, I kind of used both, didn't I?
Yeah.
You can use what you want, but I kind of used both. Focus up here, please.
Yeah.
They vary inversely. X is 6, y is 1/2. So what am I going to do there? Okay. So if xy equals k, 6 times 1/2 is k. Half of 6 is 3. So we found k to be 3. What's your equation then?
Y equals 3 over X.
Okay. It's y equals k over x, but we just found k to be 3, so it's y equals 3 over x. So the first set of numbers they give you, find k. Write your equation. If I had to guess, some of you have already finished ahead of me.
No.
Then find the value of y when x equals 15. What are you doing?
Y equals 3 divided by
Put it
15.
in the wrong one.
Y equals 3 over x, which is 15. What do you know about 3 over 15?
It simplifies to 1/5. Simplify. Simplify.
Okay.
Got it, Brady.
Okay. Now, when you flip over, we're doing the same thing 2 more times. But we're going to change it up a slight bit.
These are gonna be direct.
Probably.
No.
Oh, okay.
Our focus really is inverse variation here today. I'm teaching about both, but our focus is inverse variation. So you'll keep seeing the word inverse. But we're going from here where it just refers to x and y to they put us in a more
Try to find out what.
a real situation or more, a situation as opposed to just here's x, here's y, plug and chug.
These are
I feel like I'm in Kim 2 with this first question.
These are like those real world equations where it was like, he goes to the grocery store and buys like 3 pounds of granola.
The amount of time it takes for an ice cube to melt varies inversely to the air temperature in degrees. At 20 degrees Celsius, the ice will melt in 20 minutes. How long will it take to take the ice to melt if the temperature is 30 degrees?
I don't know.
Okay. What did you see?
Very inversely.
Yeah, what would be funny?
Okay.
Never need.
Normally, when we say varies inversely, we say y equals
Okay, we're-
k over x. And I'm just going to use that one, okay? Now, here's the deal. They don't say x is this, y is this. We need to figure that out. So, normally it's y varies inversely with x. Okay, read. The amount of time it takes for an ice cube to melt varies inversely. What's the first thing that varies?
The melt. Ice cube to melt. Amount of time.
And what is it? It's the
Amount of time.
amount of time. So normally we would say the amount of time varies inversely, so equals k divided by, what are we varying inversely with?
30
Temperature.
degrees.
Celsius. Air temperature.
The air temperature in degrees.
This is
Now, okay, give me a moment, guys. Focus. So I just need what is my y, what is my x. What varies with what? Take out the extra words. Can we agree the amount of time
just 20 minutes.
varies inversely with the air temperature? Do you see that?
Yeah.
Now, normally it's y and x. Can you keep it y and x if you want? You can. Could you change it to your own variables if that will make life better for you? You can. What would you want to use for time instead of y maybe?
T.
So you could say t. It's still going to equal, it's still going to be k divided because we don't change k.
C.
What do you want to use for air temperature in degrees?
T.
C. You can't use T twice.
A.
Okay, I have to veto t because time was t.
A.
C.
A-T. A.
I personally have been using
Degrees.
d for degrees.
Okay.
Could you use a? I'm not against it. Okay, use what you see. So, here's what we're going to do, is that it's y equals k over x, but I'm going to rewrite this as t equals k over d.
Okay. I don't like that.
Now, okay, think about what we've been doing with all the others. We decide what it is, it varies inversely. Then they give us an x and a y, and we find k.
Yeah.
That's what they're going to do here. So, at 20 degrees Celsius, what's 20 degrees Celsius going to go in for?
X.
It is your air temperature in degrees, so X, or in other words,
D.
D. The ice will melt in 20 minutes.
Ooh.
That is your time, which is T. Now I know they're both 20s, but just try and make sure we see this. So T equals 20 equals K divided by D, which is also 20. You could put this into your other form if you wanted to, but realize, how do we solve for K? K divided by 20. The opposite of dividing by 20 is to multiply. So we're going to be doing what? 20 times 20, which is going to give me 400. Okay,
That's a big K.
it is. Okay, equation. My equation, T equals, instead of K over D, 400 over D. That's the equation that represents this situation. Okay, we have a final question here. How long will it take the ice to melt if the temperature is 30 degrees Celsius?
30.
30 is a temperature, and that was, for me, it was D. So plug and chug. T equals 400 divided by 30, which is
40. Oh, never mind. 13.1.
13.3, repeating, or 13.3 what?
What?
What's a label?
R. Remainder.
13.3.
Degrees.
The label.
Degrees Celsius.
Not degrees.
T.
21.
Time.
Minutes. Oh, 13.
13.3. Good job, Joe. Yourself.
Minutes. Pop me wrong.
Okay, folks, that was a little rough. That was a little rough. Give you a basic label there.
Well,
Just saying.
we got it in the end.
T, what did T stand for? T stood for time. What unit of time was in this problem? Minutes. Okay, are we there? Okay. I don't think you guys knew what I was looking for at first, which is part of the problem, but. Okay. Let's look at D real quick, and then we'll try and squeeze in I'll squeeze in a graph.
We don't have.
But D is important. Okay? There's a slight change up.
Oh, further.
The intensity.
What?
The intensity, and that is an I, folks, because it stands for intensity. The intensity I of light received at a source, what's it vary?
Varies inversely.
Shocker, varies inversely as a square of the distance D from the source. If the light intensity is 91 foot candles at 24 feet, find the light intensity at 6 feet.
91.
Okay. The foot candles is a label. I don't know. I'm not an electrician. We're just going to go with it. Now, okay, focus with me. Y varies inversely with X. Is normally what? Y equals K over X. Got it? Now, we've got to change this up. We're going to have what? The intensity of light received at a source does what? Varies inversely. So what's my start here? Instead of Y equals, I'm going to say I equals. Now, varies inversely. Normally it's K over X, right? We're going to say K over, we don't know yet. Okay? Now, what does it vary inversely with? Square of the distance D. Square of the distance D.
D squared.
D squared is the catch. So our equation is very similar. It's just one small tweak. There's a square on the bottom. Okay? Now, that's the only tweak. Everything else, we're going to work out the same. We just have a different looking equation. What do we have here? If the light intensity is 91 foot candles, light intensity, what's the variable for light intensity? I. So what's going in for I? 91. 24 feet. 24 feet is a distance, isn't it?
Yeah.
So that's D. Can we find our K value?
Yes.
Sure can. Okay, so I'm going to do 91 equals K over 24 squared. Are you with me?
Yeah.
Now, did you go ahead and find 24 squared?
441.
So 91 equals K over,
576. 576.
yeah, 576. Okay, how do you find K? If it's K divided by 576, multiply. So 91 times 576 is
Oh.
52,416. That's K. Okay,
No thanks.
can I write my new equation?
Yeah.
I equals K, what's K? 52,416 over D squared. Read the last phrase.
6 feet.
Find the
Light.
light intensity at 6 feet. So find I. Find light intensity. Find I when what? D is 6 feet. So what are we doing? 52,416 divided by 6 squared. So 52,416 divided by 36. Told you guys you might want to calculate today.
1,456.
1,456. Now, we are trying to find I. What was intensity labeled in?
Foot candle.
Foot candles. Don't ask me what a foot candle is. I don't know. But that's what our label is.
It's a candle that goes between the big toe. That'd be dope. That's a candle.
Okay. They're word problems, yes? But notice the process is the same every time, yes? Okay.
And I don't like
Now, we're going to look at a graph down here.
We should just leave it.
We have
blank.
time.
We should leave it blank like that.
Now,
Can we do B?
on the bottom, let's go. They ask us to graph and answer some questions of y equals 6 over x. Okay? If we're graphing y equals 6 over x, what's the other version of this equation?
X, Y.
xy equals 6. Okay. Not that we have to, but I already know this is an inverse variation. It's going to be one of these graphs, whichever way I have to do that to get it right for you guys. Okay? But give me numbers that multiply to be 6.
3.
2 and 3. 6 and 1.
1 and 6. 3 and 2. Oh, yeah. 6 and 1.
And now, okay, some of you are questioning, why did you put 1 and 6 and 6 and 1? Are 1 and 6 and 6 and 1 the same on a graph?
No.
No. Now, I only filled up half my blanks. I have all those blanks there for a reason.
Negatives.
2 positives multiply to be a positive, and
2
negatives.
2 negatives multiply to be a positive. So I could also say negative 1, negative 6, negative 2, negative 3, negative 3, negative 2, negative 6, negative 1. Okay, let's graph this real quick. Right 1, up 6. Right 2, up 3. Right 3, up 2. Right 6, up 1. This is the curve in that top corner. We're going to have an equivalent curve in the diagonal corner. Left 1, down 6. Left 2, down 3. Left 3, down 2. Left 6, down 1. Is this what the graph looked like on that original, on the front page?
Yeah.
Okay. Now, first of all, notice my graphs. They're not crossing the axes. Okay? They're not going to cross the x and y axis. Okay? They're going to run along the x and y axis. Now, are we caught up on the graph?
Yeah.
X intercepts, y intercepts. Where does my graph cross the x axis and y axis? They don't. These graphs are never going to cross the x axis, and they're never going to cross the y axis. So there are no x intercepts and no y intercepts. Okay? Now, asymptotes. We'll talk about this more as this chapter goes. An asymptote are those invisible lines that a graph will come along and run along, but never cross and never touch. They can be vertical or they can be horizontal. But where does my graph never cross and never touch?
Right here.
Does it ever cross or touch the x-axis?
No.
No. Does it ever cross or touch the y-axis? No. So my asymptotes are the x-axis and the y-axis. Except here's the deal. They're not going to call them x-axis and y-axis. What's the equation name for the x-axis? Y equals 0. What's the equation name for the y-axis? X equals 0.
Yeah.
Okay? Now, domain. Where's this graph go? How far left and right? Almost. My graph goes infinitely left. It goes infinitely right. What's the one value in the middle it doesn't touch?
0.
0. So I'm going to write this as all reals except x equals 0. What about range? Range is how low and high. Take a guess here.
All
All
reals
reals,
except x equals 0.
Oh, whoa. Back up the boat, Mrs. Sargent.
Domain's supposed
Okay. Thank you. Why didn't you tell me that sooner?
Oh, I did that.
I wrote it.
I wrote it.
Okay. Hopefully, did I say x?
Yeah, you said
Okay, that makes me
but I
feel
looked
better.
up and I was like, wait,
That-
why?
Domain is always x. Range is going to be y because it goes low, it goes high, it just doesn't touch. So, all reals, maybe I was thinking ahead, except y equals 0. One last thing. Folks, this one has a negative. You know what changes? It's going to be in the opposite quadrants.
Okay.
That's what changes with a negative. Other than that, it's pretty much the same. Okay? Do the homework. Look at the homework. Bring me back questions tomorrow, okay?